In section 8.3, we're going to be talking about algebraic solutions of trigonometric equations. We're going to be solving these equations algebraically, but also with the assistance of the calculator. So the first one we're going to look at is cosine of x is equal to negative 0.02. So in order to solve this, of course, we know that the negative 0.02, it's not something we see on the unit circle, so we will need to use our calculator here. So the first thing let's talk about with this one is the fact that we need to rewrite this equation to here. Okay, this is going to help us find x. We're going to use our calculator to find x here. When we plug this into our calculator, we find out that x is equal to 1.77. Okay, now the problem with using the arc cosine here, this arc cosine, is that we have restricted our range. Our range has been restricted to values that are between 0 and pi because it's cosine. And that means that we might not get the full solutions here. And so if we look back, here's the graph, okay? Here's cosine of x, and here's where the cosine, here we have the line negative 0.2. Okay, and you can see that within one period you actually have two solutions, and we only got one of those solutions. If I enlarge that, we can see actually what those values are. One of them is the 1.77 that we got, which was here. Is here. And then the other one you have 4.51 or negative 1.77. So we need to look and try to figure out a way to get those other solutions. And we know that if we look at one period for cosine could be, from here to here, or we could say one period could be from maybe here to here. And either of those would be fine. It's just whichever one is simpler. So in this case, I noticed that what we have is 1.77. That's the solution we have. And then over here we have negative 1.77, which seems awfully convenient. And then what you're going to notice as you continue is that you're going to have infinitely many solutions, and as you continue, the equations that you would write for these two by adding 2 pi to each one would give you the other solutions. So let's go back for a second and look at what we have. So we have the 1.77. Now let's think about how we've restricted cosine. Cosine has been restricted from 0 to pi. And if cosine has been restricted there, and we've got here that cosine of x is equal to negative 0.2 somewhere over here, that means there's also going to be another solution somewhere down here. And thinking about those, if this is a certain distance here, then the negative of that would be here, which is why we need to go make sure we go back and include the second one. So if x is equal to 1.77 as a solution, then also x is equal to negative 1.77 is a solution. And that's not it. We also need to say that there are infinitely many solutions. So for each one of these, we need to add 2 times pi times k plus 2 times pi times k. And let's erase this arrow here. And of course, in this example, k is an integer. Okay, so the full solution to that is here. Okay, we have two equations. X is equal to 1.77 plus 2 pi k, and x is equal to negative 1.77 plus 2 pi k. And again, this is for cosine. And so then key here is that you need to remember that for cosine, x is going to be equal to cosine negative x. Okay. And so when we find the first solution, which was here, the negative of that is also going to be true. Okay, and now we have sine x. Okay, this time we're looking at sine of x is equal to negative 0.33. And in order to solve this one, we're going to need to use the arc sign, as we did with the cosine previously. So arc sign of negative 0.33 is going to be equal to x. And at this point, again, once again, we need to use our calculator because we know that negative 0.33 is not on our unit circle. And so when we plug that in our calculator, we get x is equal to negative 0.37, and that's approximately. So let's think about cosine, arc sine, and its restrictions. The range for that has been restricted to negative pi over 2 to pi over 2. And that restriction is going to keep us from getting the full set of solutions to our original problem. So it's been restricted to this domain, which means these were not included. And so since sine is dealing with our y-coordinate, if we have negative 0.33, there's a solution here, then there's going to be a solution over here that we have omitted. And we have to figure out how we are going to get that. It might be easier to actually look, what if it were positive here? Okay, if there was a positive solution here, then there's going to be one that's symmetric with some symmetry here. This being pi, let's say, for the sake of making this easy, that this is pi over 4. If this is pi over 4, then this here would be 3/4 of pi. Okay, so an easy connection between the pi over 4, which was the original, and the 3/4 pi would be that pi minus the pi over 4 is equal to the 3/4 pi. Okay, so, and that's because you have this. And so that's going to, using that, we'll find our other solution. And let's look at those on a graph as well. So here's the graph. First of all, of sine x, and then here, along here's the graph of negative 0.33. You can see that within a period, you would have a couple of solutions. And this one here was the first one that we found. I'm sorry, this one here is the first one that we found, which was the negative 0.37. Okay, and this is the other one we're going to find. And the way we get that is we say pi minus the negative 0.33. Sorry, 0.37, which would be this one. That should be a 7. Okay. Alright, let's move him back. Okay, so we have one solution, which we know 0.37 plus 2 pi k, because there are infinitely many of those. And then the second one is going to use, we're going to have pi minus, and then we're going to take this down, negative. Okay. So these two equations will give us the full set of solutions, and this is approximately 3.47 plus 2 pi k. Okay, so those are our two equations for the solutions. Okay, now a quick summary. When you're looking for cosine of x, you have cosine x is equal to negative cosine of negative x. And then when you're dealing with the sine, to make sure you find all of your solutions, what you have is sine of x is equal to and this is going to help us find our solutions. Okay, now we are dealing with tangent, and tangent's a little bit easier because our period is pi. And so for this one, we just need to use our arctangent. And once again, we can use our calculator for this. And we would find out that x would be equal to negative 1.33. Now from here, there's not one solution. Remember that the domain here is negative infinity to positive infinity. Because we used this, we had some restrictions on the range, which means that's why we have exactly one solution when we should have infinitely many solutions. So we need to add to this plus pi k. Pi this time instead of 2 pi because the period of tangent is pi and not 2 pi. So solution would again be given as an equation. Okay, now we get a little more interesting with cosine here. First we need to isolate cosine of x just as we do with any other type of equation. So 3 cosine of x is equal to negative 1, and that means that the cosine of x is equal to negative 1/3. Okay, at this point we need to go ahead and deal with the arc cosine of 1/3 is equal to x. And this should be negative. We use our calculator for this, and we would get that x is equal to 1.91. But we know, of course, that there are infinitely many solutions that are, we can just add 2 pi k to that, because the period of cosine is 2 pi. And then we need to find the second solution within that one period. And the way we do that is we just take the negative of the previous and add 2 pi k. All right, and so these are solutions, and of course in all of these k is an integer. Okay, now we have example 5. This time we have the sine of u is equal to 1/2. This time we're going to find it exactly without using the calculator, and we know we can do that because we recognize this as being on the unit circle. So still you can think about this, but this time we know that the sine of pi over 6 is actually 1/2. But at the same time, you might be able to think about what the other solution is, which would be 5 pi over 6. And notice that 5 pi over 6 can also be written as pi minus the pi over 6, had you found that with your calculator. And for each of these, we need to add our 2 pi k to get the full set of solutions. Okay, so once again, we're going to do this one without using the calculator at all. You notice that we have a 4x here, which is going to give us, make this problem a little bit more interesting. So let's start out by saying the arcsine of root 3 over 2 is equal to 4x. At that case, we know that the angle that we would be looking for here would be pi over 3, because the sine of pi over 3 is root 3 over 2. And now we need to bring down the 4x in this case. Okay. So the solution, as long as this is 4x, is pi over 3. So what does that mean? Means a couple of things. First of all, we know that 4x is equal to pi over 3 plus the 2 pi k, because there are infinitely many solutions there. We also know that we can simplify this here, but let's go ahead and write the other equation first. We also know that 4x could be equal to the pi minus the pi over 3, which we could have found that one anyway without using our calculator. And when we simplify each one of these, we would get our final equation. So here I would divide everything by 4, which is the same as multiplying by a fourth here. Divide by 4. And so I would get x is equal to pi over 12 plus pi k over 2. That's one equation. And then my second equation would be divide everything by 4 again, or multiply by a fourth. Okay. And I get x is equal to, in this case, we're going to simplify this here to 2 pi over 3. And then when we multiply by 1/4, we end up getting the pi over 6 plus pi k over 2. Okay, and so we have our two equations, our two final equations for solutions, which would be here and here. Okay, now for example 7, this one is going to take a little more work. We're actually going to be doing some factoring on this one. So if you think of this equation as something more like this, then you can understand with a little more ease how to factor it. So this we know we would factor as 4x plus 1 times x plus 1. Okay. And in these cases we don't just have x, it's not only the x we have, but we have the sine of x. So what we can do to factor this equation, the one that we're dealing with, is 4 sine x plus 1 times sine x, with a coefficient of 1 of course, plus 1 is equal to 0. And then we have two simple equations to solve that are much like the previous. So zero product property means that we know that 4 sine x plus 1 equal to 0, sine x plus 1 is equal to 0. At least one of those two has to be equal to 0. And if 4 sine x plus 1 is equal to 0, then we know that the sine of x is equal to negative 1/4. Okay. And let's go through and solve this one first. So if the sine of x is equal to negative 1/4, then we can write the equation, which is going to restrict us, but that's okay. We'll take care of it with our equations in the end. We get this, and so we use our calculator to find out. We get approximately negative 0.25. So that's a step where we need to use our calculator. But we know that we were restricted in our range here, and so there's also going to be another solution, which we would find by saying pi minus the negative. Okay, which in this case would give us, actually we could just, actually it's fine to leave it like that, but let's just write it as pi plus 0.25. Okay, and so with both of those would need to become equations. So we say plus 2 pi k plus 2 pi k. And so we have these. That would have plus 2 pi k too. And this one. But if you notice in the end, what we're going to need to do is make sure it's on this interval from negative pi to pi. But we'll take care of that in just a few minutes. Let's go ahead and solve the second equation now. So for this second equation, we're going to have that the sine of x is equal to negative 1. And that's something we're pretty familiar with. We can rewrite it if we want, but we might just know that the answer to that is negative pi over 2. Okay, And so, of course, dealing with -1, you're only going to have, in one period, you're only going to have, that is only going to happen one time. It's not like the others, and that's because, here it's only going to hit that -1 exactly. It's going to hit it exactly once. And so if you were to do your subtraction, you would notice that pi minus the pi over 2 is going to continue to give you something that you would arrive at using the equation to begin with, because this would be plus pi over 2, and so then you would get 1.5 pi, which you would get by just using the negative pi over 2 to begin with. So it's not necessary to do that in this case because of the fact that you hit the -1 in exactly one case. So we do still add the 2 pi k to this. All right, and so we have this equation. All right, so keep in mind it's asking us, well, what are the solutions along the interval from -pi to pi? And so what that means that we need to do is we need to start looking at each one of these. And of course this -0.25 from this equation is going to work if k were 0. So we take that one, of course. And then in the next one, what you want to do is plug in values for k in each one of these and find out how many solutions you get between the interval of -pi to pi. So -0.25 would work, -2.89 would work, which comes from this one. And then we would also have -pi over 2, which comes from here just by having a k value of 0, would also work. So in the end, we do not have equations for solutions, we actually have exact values for solutions, or an estimate. All right, and this is our last example. In this example, we're also going to factor. First of all, I'm going to rewrite this equation as cosine x times sine squared x minus cosine x is equal to 0. At that point, I realized that I can factor out a cosine x. And I end up with this. And again, I need to use the zero product property. Cosine x is equal to 0, or sine squared x minus 1 is equal to 0. Okay? So two equations I'm dealing with now. And so for the first one, cosine x is equal to 0. I know that in this case, I'm going to have x is equal to pi over 2. Okay? It's also equal to negative pi over 2. You could do both of those. Plus, but pretty quickly you'll realize these two are actually going to give you the same thing. So it's fine to just use 4 to represent both of them. As k changes, basically what will happen is you'll get the same values for using both of the equations. So I would probably just end up using this right here so that you're not repetitive. So there's one equation. And then for the second one, let's isolate the sine squared x is equal to 1. And when we take the square root of both sides, sine x is equal to plus or minus the square root of 1. So sine x is equal to positive or negative 1 is what we end up with. And so dealing with the sine of x is equal to 1 and the sine of x is equal to negative 1, we actually end up with two separate solutions. First of all, in this case, you get pi over 2, and in this case, you get negative pi over 2. Okay, and both of those need to be equations. Okay, so these are the three equations that would represent our solution set. And that's all I have for section 8.3.